In this chapter, we will be learning about logarithms. In this lesson, we will be converting between forms to help us simplify logarithms.
Okay, so what we're going to do here is we're going to practice a lot of going back and forth between the two forms of the inverse of the exponential function, okay, the exponential form and the logarithmic form, and use that to practice simplifying. Okay, so remember that when you take the exponential form, so we had y equals a to the x. When we did that to find the inverse, okay, we got x equals a to the y. That can either be written as x equals a to the y or log base a of x equals y. Remember, the bases are the same, and a logarithm is equal to an exponent. Okay, and then we take the log of whatever that power was equal to. So the log base a of x is equal to y, the exponent. That's what we're going to apply repeatedly in this lesson.
Convert to exponential form and solve for y. Log base 7 of y divided by 3 equals x.
Okay, so here we go. So notice that the base of the logarithmic function here is 7. So the base of our exponential function is going to be 7. A logarithm equals the exponent, so this is going to be 7 to the x. And we always take the log of whatever the exponential function equals. So it's going to be y over 3. And now our job was to solve for y, so to get y by itself, I would multiply both sides by 3. And I'll bring the y over here because it looks better over here. So y is equal to 3 multiplied by 7 to the x. That's what we're looking for.
Log base 5 of 7y equals x.
All right. Now, once again, the base of the logarithm is 5, so the base of my exponential is going to be 5. A logarithm is an exponent, so this will be 5 to the x. And a logarithm, we always take the log of whatever the power is equal to. So 7y. So 5 to the x equals 7y. Now to get y by itself, I'm going to divide by 7. And again, I'm just going to write the y on this side because it looks better. And this will be 5 to the x divided by 7. That's what we're looking for.
4 multiplied by log base 2 of y equals x.
Okay, so for this one right here, the very first thing I got to do is isolate the logarithm. Okay, I want that log all by itself. I don't want that 4 in front here because I can't convert to the logarithmic form. Okay, if there's something more than an exponential form, I can't convert to the exponential form if there's something more than just the logarithm there. So I'm going to divide, and we'll get the log base 2 of y is equal to x over 4. Now it's in the logarithmic form that I need it to be in. So the base of the logarithm will be the base of the exponential. Okay, so we're going to get 2 to the, and a logarithm is the exponent, so 2 to the x over 4. And this is going to equal, remember that the power here always equals what you're taking the log of. So there we go. 2 over to the x over 4 is equal to y.
Convert to logarithmic form. X to the 2y is equal to 5.
Okay, now for this one, we're going to go backwards here. So here's our power. Our base is going to be the same when we convert it to the logarithmic form. So this is going to be the log base x. Now, what the logarithm is going to equal will be the exponent. So the logarithm is going to equal 2y here. And then remember, we always take the log of whatever the power equals. So this is log base x of 5 is equal to 2y. Okay. And if the rule here is still to solve for y here, then we would divide by 2. So maybe we'll put the y over here and make this, I don't know, 1/2 log base x of 5. That looks a little better.
X is equal to 2 multiplied by 3 to the y.
Okay, now before we can convert this into the logarithmic form, just like the issue that we had in a previous question here, we have to isolate the power. Just like in a previous question we had to isolate the logarithm. Here we've got to isolate the power here. That 2 is not part of the base. Okay, it's multiplied afterwards. So we're going to divide through by 2 first. Okay, now to convert this to the logarithmic form, notice I'm going to have the log and it's going to be base 3 because the base of the log is the same as the base of the power. The logarithm is equal to whatever the exponent is, and you take the log of whatever the power is equal to. So log base 3 of x over 2 is equal to y. Now, normally I'd bring that y over and isolate it, but it's already isolated, so there's no point.
5x is equal to 30 to the y.
Now, for this one here, don't get thrown off and want to divide through by the 5 here. The power is already isolated. This is okay. You don't need to do anything right now to this. You certainly can't divide and simplify this, like divide both sides by 5 and make this go to 6, okay? Because order of operations would say that you would have to do the exponent prior to the division. So in this case right here, the best we can do here is just jump right in. Okay, the base of the power is 30, so the base of the logarithm is going to be 30. The logarithm is always equal to the exponent in the power, and you take the log of whatever it is the power is equal to. So the log base 30 of 5x is going to equal y. That's what we're looking for.
X is equal to 3 halves of 10 to the y.
Now this one's a little different than the previous one because in this case I do have to isolate the power. I've got to get rid of this 3 halves here, so I'm going to make this 2x over 3. Okay, I'm going to multiply by 2, I'll divide by 3 to bring that coefficient over. Now I can write log base 10, okay, and this is going to equal y, because remember the logarithm is always equal to the exponent, and we're going to take the log of whatever the power was equal to. So 2x over 3. So the log base 10 of 2x over 3 is equal to y. Now, we're going to anticipate where this is going here in just a second. There's a little note here right underneath this question here about common logarithms. If the log is base 10, we don't need to write it. So in this case right here, I could write this like this. Y equals the log of 2x over 3. If I write it like that, then it's understood that this is a common logarithm. Okay? And so you can see what we're getting at right here. So if you see log of 3, that means log base 10 of 3. It's like when you write a square root. You don't need to write the 2 in there to indicate a square root. It's just understood that that's a square root. Same thing here. If you just see the log without a base, it is understood that the base is 10.
Evaluate the following logarithms using your calculator.
Okay, so we have just talked about what it means to be a common logarithm, that when the base isn't written, that the base is 10. Now if you go to your calculator and you just take a look on this left-hand side here, you're going to notice your log button here. That button right there is a common log. It's base 10. And in fact, you'll see up here, the inverse of it, a power of 10. Okay, so this is what we're going to use right now. So we're going to just use our calculator. We're going to go through and evaluate all of these. So I'm going to press that log button. I'll enter 10 here. Now just think about this. Just think about this. What we're asking here when we take the log of 10 is what power of 10, the base, gives me 10, the number? The answer is it should be 1. It should be 10 to the 1 gets you 10. And there it is right there. We're getting a 1. So the log of 10 is 1. Now we're just going to do all of these right now. So log of 1,000. Okay, so I press my log button. 1, 2, 3. Now let's just think about this. Let's see if we can predict this. The base here is 10. So the question is what exponent, okay, because that's what this is going to give, what exponent on 10 creates 1,000? 10 to what exponent is 1,000? Well, 10 cubed. So this should be 3. And there it is. So this is equal to 3. Okay, so now let's take a quick look at this one right here. So look where the decimal is. It's been moved 1, 2, 3 to the left here. So I'm anticipating that this is 10 to the negative 3. Okay, so that makes sense here, 10 to the negative 3, because the negative is going to move the decimal this way, positive is going to move it this way. Let's go to the calculator here. Whoops, not 10 to the negative 3, we're going to do log. Log of 0.001, and there it is. That's what we're looking for, negative 3. So this is going to equal negative 3. Good.
Estimate the log base 5 of 80.
Okay, so in this question right here, we're going to introduce what we call the change of base identity, and I'm going to show you the equation in just a second here. But before we do that, we're going to estimate this here. Now take a look. This log base 5 of 80 is what? Well, let's just take a look and see if we can think our way through this. So log base 5 of 80 is equal to y. Let's say I don't know what it is. I can't figure this out right now. Let's convert this to the exponential form. What this would be is base 5 to the y is equal to 80. Okay, well, okay, y if this was squared, if y was 2, 5 squared would be 25. Okay, if this was 3, 5 cubed is 125. Okay, so this is in between there, right? It's, what is it, from 25 up to 80. Okay, we're looking at 55 there. And then back from 125, what were we losing? 45 here. So this is probably closer to 3. So I don't know, we're maybe saying, like, let's say that this is going to be, let's say 2.7. Not entirely sure. Best guess here, okay? Now, change of base identity. If you use this formula, if you're looking at log base b of c, I can change this to whatever base I want as long as I take the log base, my base of c, and divide that by the log base, my base of b, the base right here. So that argument goes up here, the base goes down here. Now normally I'm probably going to change this everything to a base 10 because I have base 10 on my calculator. So let's come back to this. Log base 5 of 80. Okay, I'm going to change the base here and make this the log base 10 of 80. And remember, I don't need to write it if it's base 10. Divided by the log base 10 of 5. Now I can do this on my calculator. Whoops. So I will make this the log of 80, log base 10 of 80, and I will divide this by the log base 10 of 5. Yeah, and I got 2.7. 2.72. So that's a good guess on my part. 2.7. So that's how you would do that.
Convert the following to logs to the base indicated.
Okay, so to convert log 6 base 16 of 8 to base 2, what we're going to do here is take the log base 2, actually I should probably write it out like this. Log base 16 of 8 is going to equal the log base 2 of 8 divided by the log base 2 of 16. Now, we can evaluate this, okay? We can actually figure this one out here because I know that the log base 2 of 8 is going to be 3. 2 cubed is equal to 8. I also know that the log base 2 of 16 is going to equal 4 because 2 to the 4 is equal to 16. And so the overall answer to the log base 16 of 8 is going to be 3/4. Okay, but this is what we're asked to do in this case right here. So for this one over here, we're going to do a very similar sort of thing. So the log base 9, whoops, I was going to write 80 there for some reason. Log base 9 of 30, if I'm going to convert this to base 3, this will become the log base 3 of 30 over the log base 3 of 9. Okay, so now I've converted this to base 3. Now I can go a one small step further. I don't know what the log base 3 of 30 is. Okay, I don't know what that is. But I do know what the log base 3 of 9 is. That's going to be 2. So this is like the log base 3 of 30 over 2. And that's what we're looking for. Now you could write this as 1/2 log base 3 of 30. Just make sure that you realize that a half of something is the same as dividing it by 2, okay? No big surprise.
And now we will look at a small number of logarithmic identities.
Okay, now just for a couple moments here, let's take a look at some of the rules that they won't be given to you. Okay, a lot of the rules that we're going to look at in terms of logarithms will be on your formula sheet, but these ones won't. Okay, so for example, the log base a of 1 is equal to 0. Okay, doesn't really matter what our base is as long as it's an acceptable base. Log base a of 1 is going to be equal to 0, and that's because 1 is always going to equal that base to the power of 0. Okay, over here, log base a of a is going to be 1 because when you put this back in exponential form, a is equal to a to the 1, and that makes sense. Now here, these two here are a little bit more confusing. Okay, but I hope they're going to make sense to you here. Log base a of a to the x is equal to x. Essentially what this is saying here is what exponent do I have to put on this base a to make it a to the x? Well, it's just x. It's got to be, and it's true because a to the x equals a to the x. That one is kind of just straightforward. But the reason why I think some people have problems with it is because sometimes it's so straightforward it goes by so quickly. It's hard to see that. Okay, this one here is a little bit more difficult. A to the log base a of x is equal to x. Now, I tell you what, let's take a quick look at that. When we talk about a to the log base a of x, and we're going to say I don't know what that is. Typically the issue here is this exponent. I'm not entirely sure what to do with the exponent, so I'm going to make this y equals log base a of x. Okay, so in other words, what I've got here is a to the y. That's what I'm going to do. I'm going to replace that. Now, convert this into exponential form. Well, a to the y, okay, the base of the logarithm is the base of the power. The logarithm is the exponent, and then the power equals whatever I'm taking the log of. A to the y equals x. And you see, right there, that's our solution. A to the log base a of x, we said was going to be a to the y, and I've just demonstrated that that is equal to x. So there it is, they're equal to x here. Another way to think about it is the logarithmic function and the exponential function are inverses of each other. And when they have the exact same base, really what they're doing is in essence canceling each other out. And so you're just going to be left with that value that's inside the expression there, okay? The log base a of a to the x. A to the log base a of x. That's the number that's going to pop out.
Evaluate the following. Log base 2 of 8.
Okay, we're supposed to evaluate these things here. So log base 2 of 8. Okay, let's just say right now I don't know what that is. So I'm going to say that that's equal to x here. How do I deal with a logarithmic expression here? Well, I'm going to convert it to an exponential one. So 2 to the x is equal to 8. Now, I can make these powers with the same base here, because I know that 8 is equal to 2 cubed, and so this means x is equal to 3. So I know that the log base 2 of 8 is supposed to be equal to 3. So if you're struggling to kind of make the connection between the base and this argument here, and how this works here, this is essentially asking 2 to what exponent gets you 8. So I'll do this a couple of times like this, and then what I'll do is we'll just start to talk about it in terms of that little connection right there.
Log base 5 of the square root of 5.
So as we did with the previous question, what I'm going to do here, I'm going to set this equal to x to start off with. So to evaluate this, I'm going to take this expression here, this equation here, I'm going to convert it to exponential form. So 5 to the x is equal to the square root of 5. And then I know that this is a power of 5. The square root is the same as taking it to the 1/2. And now because powers are the same, bases are the same, I can tell you that x is equal to 1/2. So up here, this expression is equal to 1/2. Okay, so again, I could ask myself, though, in a simpler way, what exponent would I have to take 5 to make it equal to the square root of 5? And the answer is 1/2.
Log base 6 of 6.
Okay, now this one right here really shouldn't require any effort whatsoever because it's one of the rules up here. Okay, log base a of a is equal to 1. Well, log base 6 of 6 must therefore be equal to 1. That's just a direct application of that little rule.
Log base 9 of 81.
Okay, now let's start to move through this a little bit quicker here. Log base 9 of 81 is equal to what? Well, the question is, 9 to what power is equal to 81? That's what this is asking for here, and the answer is 2. 9 squared is 81. That's the answer that we're looking for. So log base 9 of 81 is 2.
Log base 2 of 0.25.
Now it might help in this particular case here to rewrite the argument here. So this would be log base 2 of 1/4. Okay, and now we got to ask ourselves, what exponent would I have to take 2 to get 1/4? Well, I know that it's going to have to be negative because I got that 4 in the denominator, so it's going to be negative. And to get 2 to become a 4, I have to square it. So this has to be to the negative 2. This has to be 2 to the negative 2 is equal to 1/4. So that in turn is what you'd get when you go log base 2 of 0.25.
Log base 2 of the square root of 1 over 512.
Okay, now for this one right here, it would be nice if I could just say 2 to what power gets me this right here, but you know what? I suspect that this one's going to be a little bit harder to work through because there's a lot more going on in this question. So let's go back to our first way of doing this. Let's just make this equal to x, and then we'll evaluate for x here. So we're going to put this into our exponential form. So 2 to the x is going to equal the square root of 1 over 512. Okay, well first of all, that square root there is going to be 1 over 512 to the 1/2. Okay, now that 1 over 512, now 512 is a power of 2. Okay, you might have to play with this a little bit, but that is going to be 2 to the 9. Now bring that up into the exponent. This becomes 2 to the negative 9 all to the 1/2. And so there it is. This becomes 2 to the negative 9/2. Okay, so it took me a little while, but I took that square root of 1 over 512, converted it to a power of 2. Now, if the powers are the same and the bases are the same, the exponents must be the same, which means in this case right here, x must be negative 9/2. There we go. Took a little bit, but we got there.
Evaluate the following. The common log of 100.
All right, now in this case right here, remember that if the base isn't shown, the base is 10. This is a common logarithm here. So now my question is, what power or what exponent on 10 creates that 100? That's what I'm asking for here. And a little bit of thought should tell you that that has to be 2. So the common log of 100 must be 2.
Log base 5 of 25.
Okay, so this one here, log base 5 of 25. Now this is asking me what exponent do I have to put on 5 so that it becomes equal to 25. Think about it for a second, it's got to be 2. 5 squared is equal to 25.
Log base 3 of 81.
All right, now this one might take a little bit more thought, but hopefully you've seen this pattern before. Again, we're asking what exponent do I got to put on 3 to make that equal to 81? Now, we all know 3 squared, 3 cubed is 27. It's the next step up. 3 to the 4th is equal to 81. So that means the log base 3 of 81 must be equal to 4. That's how we handle that one.
Log base 6 of the square root of 6.
Okay, so we've got here the log base 6 of the square root of 6. So again, the question is, what exponent do I put on 6 to make it equal to root 6? Okay, well, what causes that square root to happen here? Well, a fractional exponent. In this case, because it's a square root, it's got to be 1/2. So log base 6 of root 6 has got to be equal to 1/2.
Log base 11 of 11.
All right, log base 11 of 11, that's a great one because it's one of the patterns that we saw earlier on here. That immediately becomes 1. And that's easy to see because what power of 11 gets you 11? Well, just 11 to the 1.
Log base 8 of 1 over 64.
Okay, so there's a little bit more going on in this particular problem here. So let's set this one equal to x here. I know that 8 to the x is going to equal 1 over 64. Okay, and whoops, sorry, I don't know why I wrote that. That was weird. I meant 8 to the x equals 1 over 64, not 8 to the 8. 64 is going to be 1 over 8 squared. And then I got to get that up from the denominator, so 8 to the x is going to equal 8 to the negative 2. So that means that my exponent here, the value of this logarithm must be negative 2.
5 to the log base 5 of 125.
Okay, now this should be a straightforward one here. 5 to the log base 5 of 125. If you compare that to one of the rules that we saw in the box above here, you'll notice that we've got a base of 5 in the power and then a base of 5 in the logarithm. Those are inverses of each other, so the answer here has got to be 125. Okay? Now if you're not comfortable with that, what you can do here is set x equal to that exponent, log base 5 of 125. Okay? 5 to the x, if you convert this to an exponential form, is 125. That's just 5 cubed, so x is equal to 3. But remember, x isn't the answer, x was the exponent. Okay, that's what I did here. I let x be equal to the exponent right there. And so now 5 to the x, or 5 cubed, there's my 125. So it doesn't really matter how you play that, you're going to get 125 as a result.
Log base 2 of the square root of 1 over 16.
Okay, here's another one that I'm going to set equal to x and then work my way around it. So first of all, convert this to the exponential form and we get 2 to the x is equal to root 1/16. Okay, so the root 1/16, first of all, is going to be 1 over 16 to the 1/2. Okay, 1 over 16, that is 1 over, I want this as a power of 2, sorry, I want this as a power of 2 here, so 1 over 2 to the 4th to the 1/2. I've got that term in the denominator, I want it up, so I'm going to make this 2 to the negative 4 to the 1/2. And then when I've got a power of a power, just multiply the exponents. This becomes 2 to the Well, half of negative 4 is going to be negative 2. So therefore, x has to be the same as negative 2 because I've got power equal to power and the bases are the same. So that means the value here, the log base 2 of the square root of 1/16, must be negative 2.
Solve the following by first converting to exponential form. Log base 2 of x equals 5.
Okay, so to solve for this here, we're going to convert this to exponential form. And really, anytime you've got a logarithmic equation, that is going to be our standard way of doing this here. Because I got to get rid of the log. Okay? To solve a logarithmic equation, I have to get rid of the log. It's just like when you're solving a square root equation, you need to get rid of the radical. If you're solving a rational equation, you want to get rid of the fact that there's a denominator there. It's just you're dealing with the part of the function that makes it that kind of a function here. If it's an exponential function, you want to start to deal with getting rid of that exponent there. So convert this to exponential form. So 2 to the 5 is going to equal x. And now the benefit here is immediately I've got x isolated, and 2 to the 5, okay, is just going to be 32. Okay, so there's the solution to my equation.
3 equals the log base 5 of x.
All right, another logarithmic equation. So the way I'm going to approach this here is to convert this to the exponential form. So the base is 5, and the exponent here is going to be 3 because a log is an exponent. So 5 cubed will equal whatever it is that we're taking the log of, and 5 cubed is 125. So x must be 125.
Log base 5 of x equals negative 2.
Another logarithmic equation. So again, my goal here is to convert to the exponential form. The base is 5. The logarithm is the exponent, and that will equal whatever it is you're taking the log of. So that negative is going to force a reciprocal to occur, and then 5 squared is 25. So my answer here is x is going to equal 1/25.
Log base 5 of the square root of 125 equals x.
All right, now this isn't actually a logarithmic equation. Okay? It isn't, because the x, the independent variable, is not part of the logarithm. It's not in the logarithm. Now, I still don't know what x is equal to. I mean, I do. It's the log base 5 of the square root of 125, but I don't really know what that is. So really what this question is about evaluating what this is. So let's make this 5 to the x is equal to the square root of 125. I know that the square root is going to introduce an exponent of a half. And then I know that 125 is going to be 5 cubed. So I've got 5 cubed to the 1/2. So this really becomes, when you multiply the exponents together, whoops, I don't know why I wanted to put another 5 up there. But this becomes 5 to the 3/2. Powers are the same, bases are the same, so this must in fact be 3/2.
2 multiplied by the log base 8 of 512 equals x.
All right, this is similar to the one that we just did in that this isn't a logarithmic equation so much as just an opportunity to evaluate this. So we've got 2 times the log base 8 of 512. Okay, in order for me to convert this, because the question wants us to convert to exponential form to evaluate these, I'm going to have to isolate the logarithm here. So I'm going to bring the 2 over, make this the log base 8 of 512, and that'll equal x over 2. And now the base is 8, so this becomes 8 to the x over 2 is equal to 512. Okay, now both of these can be written as, well, how do I say this? Both of these can be written as powers of 2 here. So this will be 2 cubed to the x over 2, and 512 is 2 to the 9. Okay, so now I've got 2 to the 3x over 2, because when I got power of a power, you multiply them together. This is going to equal 2 to the 9. So powers are the same, bases are the same, so the exponents must be the same. So now I can multiply that over. 2 times 9 is going to be 18. And when you divide by 3, we get 6. Now it took us a little while here, but there we go. So we know that the value of x here must be 6. Okay, so 2 times the log base 8 of 512 must be 6.
5 equals 4 multiplied by the log base x of 32.
All right, now here's another one that's a little on the odd side here, because look where the x is. Now, this is, I don't know. Right off the top of my head, I don't know if you'd call this logarithmic or not, because the x is in the base here, not within the logarithm. In any case here, I still got to get x by itself. I got to isolate it. I got to take it out of that logarithm here. Now, before I can convert forms here, I really got to isolate the logarithm. So this has got to become 5/4 is equal to the log base x of 32. Now, let's convert forms here. This becomes x to the 5/4 is equal to 32. And see, now this isn't an exponential equation because the variable here is in the base. So what I'm going to do here is raise both sides of this to the reciprocal exponent, and I'll get x is equal to 32 to the 4/5. Remember that what this means, this is the 5th root of 32, and it probably makes sense to evaluate that to the exponent 4 after you take the 5th root, because you make the number smaller and then you make it bigger, instead of making it ridiculously large and then making it smaller. So the 5th root of 32 is going to be 2. 2 to the 4th is 16. So x in this case, now I would like to say it's equal to x, but x is kind of locked in there. So essentially, just at the bottom here, I'm just going to have to write x is equal to 16.
Log base x of 36 equals 2.
All right, here's a similar sort of problem to the one that we just did. So what we've got here is the base here is x, the exponent is 2, so x squared is equal to 36 when I convert that to the exponential form. Again, this isn't exponential though, okay? This is the exponential form of this logarithmic expression. But now that you look at it and identify where the variable is, you wouldn't call this an exponential equation because the variable here is in the base. So what I'm going to do is I'll raise both sides to the 1/2. That'll get me x is equal to the square root of 36. And in this case, it would be 6. Now, you might argue here, well, wait a minute, shouldn't that be plus or minus 6? Root 36, so plus or minus 6. And I would be inclined to agree with that analysis here. However, because it's in the base here and we have a restriction that the base can't be negative, you're going to get it as just positive 6.
Log base x of 9 equals 2/3.
Right, so this question can be solved the same way that we've done the last few here. We're going to convert this to the exponential form, so x base to the exponent, which is what the logarithm is equal to, and that's going to equal whatever we're taking the log of. Again, this isn't exponential, okay, because the variable is in the base here. So what I do is I raise both sides of the equation to the reciprocal exponent, and I get x is equal to 9 to the 3/2. So that is the square root of 9 cubed, and this is actually fairly straightforward. It requires a little bit less effort than some of the other things that we've done because it's more familiar. Because we know that the square root of 9 is 3, and then 3 cubed is 27. So in this case, the base here, x, is 27.
Log base 16 of x equals -1/4.
All right, with this question, we're back to something that is clearly a logarithmic equation because the variable is inside the logarithm. Okay, it's not part of the logarithmic expression, it's right there. So now we're going to convert this to the exponential. So 16 to the -1/4 is going to equal x. Okay, base to the exponent is going to equal whatever we're taking the log of. And now, okay, that negative is going to cause a reciprocal. And this is going to be the 4th root of 16. And in this case here, the 4th root of 16, you just think about it for a second here, that's just going to be 2. So the negative causes a reciprocal, and then we've got the 4th root, and then we take it down to 1/2 here. Please remember at this point, because it's going to be easy to fall into this little trap here, that negative does not affect the sign of your answer. Okay, what that does up in the exponent is cause a reciprocal to happen. Just try not to make that mistake. It's going to be very easy because there's so many other things going on here now that you got to pay attention to. That little detail, though, that's really frustrating when mistakes like that slide in. So just be careful.
Log base 2 of x over 4 equals 3.
Okay, once again, the thing that we're working with here is a logarithmic equation because the variable is within the logarithm. We'll convert to the exponential form, so 2 cubed base to the exponent, and that power will equal whatever it is we're taking the log of. I don't exactly know why I put parentheses there, to be honest with you, but anyway. So we know that 2 cubed is equal to 8. And then for me to get the x by itself, I'm just going to multiply through by 4, and I'll get 32. Whoops, 32. 32 is equal to x. Okay, that one kind of fell into our lap really quickly, nicely.
Log base 2 of x over 5 equals negative 3.
Okay, another logarithmic equation here. So again, I'm just going to convert forms here. So base is going to equal the exponent, the logarithm equals the exponent. So 2 to the negative 3, this will equal x over 5, whatever we're taking the log of. Okay, 2 to the negative 3, the negative is going to cause a reciprocal to occur, and 2 cubed is going to be 8. And then for me to get the x by itself, I'll multiply both sides by 5, and so what will end up happening here is x will equal 5/8. That's not a particularly wonderful value to get as a result, but it's good. That's fine.
2 equals the log base 4 of 32 multiplied by x.
Okay, this one is still a logarithmic equation, but there's a little something else going on here. Notice that what's inside the logarithm is a little bit more complicated. Now in the previous questions, it was also a little bit more complicated, but it was easier to see here. Just recognize that whatever comes after the logarithm, like if there was something multiplied by the log, we would put brackets around the whole thing. So typically, if you don't see the parentheses here and you see kind of a bunch of things multiplied together, the assumption is that is all within the logarithm. So it's just a little less clear here than it is in the previous one, but that's all we're doing. So now this logarithm is isolated because all of this is inside it. I'll just convert forms. Base to the exponent is going to equal whatever we're taking the log of. Okay, 4 squared is going to be 16 is equal to 32x. And now I'll just divide by 32 to get that x is equal to 1/2. Okay, now at this point right here, it just occurred to me that you need to be careful with this. There's been a recent kind of surge in this kind of mistake happening where people look at this right here and say, oh, x must be 2. So watch out for that mistake here where you're very tempted to want to just divide by 16. It seems to be that a lot of times people are so against fractions that they don't want to work with it or don't want to see them pop up here. So remember that to get the x by itself, you're dividing by the 32. I apologize if you don't like fractions, but that's what you're stuck with. Okay, please be careful of that. You can always check it too here. If you thought the answer was 2, just plug 2 back in here. It's 32 times 2 does not equal 16. Okay, just check your answer.
If the log base 2 of x equals 3 and the log base 2 of t equals x, determine the value of t.
All right, well, questions like this tend to be kind of a multi-step problem here. They're just kind of linking, or there's kind of a chain of thinking here. So first of all, we're told that the log base 2 of x is equal to 3. Now what that means is 2 to the 3 is equal to x. I mean, I can solve this for x. I'm going to get here that x is equal to 8. Okay, so it's not all that hard to work with here. Now, once I've got that bit of information, I can come over here, and then I know that the log base 2 of t must equal 8. Now, I can solve this logarithmic equation by again converting to the exponential form, and I'll get 2 to the 8 is equal to t, and 2 to the 8 here is 256. And so that's the idea that they're looking for. That's the number that they're looking for, but that's the process here. I'm using this to get the value of x here that I then put into this one to solve for the value of t. So there's this little chain of thinking that has to go on here.
If log base a of b equals 4.5 and log base a of c is equal to 3.7, then the value of the log base a of b divided by c to the nearest tenth is what?
Okay, for this one right here, I'm given a bunch of information up front here. Later on in this chapter, we're going to come back to questions like this, and we're going to solve it in a different way. But for right now, look at what's going on here. I'm giving you some information about log base a of b, log base a of c. Over here, I've got log base a of b over c. Now, I'm supposed to evaluate what this is. Now, if I could get this to some power of a, then I would have one of those little log rules that I looked at before. Log base a of a power of a is just the exponent. So I kind of want to do that. So what I got to do here for each of these is convert these things to exponential form. So log base a of b equals 4.5 means a to the 4.5 is equal to b. Base to the exponent is equal to what I'm taking the log of. Same thing over here. Base to the exponent, okay, to what the log equals, is equal to what I'm taking the log of. So a to the 4.5 is b, a to the 3.7 is c. So now I come over here. Now I can make a direct substitution here. This will be the log base a of, well, b was a to the 4.5, and c was a to the 3.7. I'm dividing powers, so I'm going to subtract exponents. So this will become log base a of a to the 0.8, okay, because 4.5 minus 3.7 is going to be 0.8. And now I've got that pattern that I saw before in that little chart there. Log base a of a power of a is just going to be that exponent. Okay, you can see that on the top of the previous page there in that box. And so that's the answer that I'm looking for, 0.8.
If the log base 2 of the log base 3 of the log base 2 of x equals 1, then x is what?
All right, now this question right here is just, and you can see it right here, is just a nested set of logarithms, okay, a log within a log within a log. Okay, so I know that that whole thing here is equal to 1, and I got to work my way into x here. So what I'm going to do here is basically knock off the outside, and then the outside, and then until I'm left with just that x there. So to start off with, I've got this log of something equals 1. I don't know what it is. So it's like the log base 2 of my thumb is equal to 1. So that means 2 to the 1 is equal to my thumb. Well, what was my thumb covering? Well, it was covering this. So this is going to be log 2 to the 1 is equal to the log base 3 of the log base 2 of x. Okay, so that was my thumb right there. There we go. And that's equal to 2 to the 1, which is just 2. Now I'm going to do this again. Log base 3 of my thumb is equal to 2 to the 1. Now I'm going to convert this to the exponential form. So 3 to the 2, 3 squared, is going to equal what I'm taking the log of, my thumb. And my thumb was covering the log base 2 of x. Okay, well now before I convert this to exponential form again, just 3 squared is 9. Let's just write it like that so it's a little bit easier to work with. And now log base 2 of x is equal to 9. Convert that to exponential form means 2 to the 9 is equal to x. Okay, and we've already worked even with these values before. 2 to the 9 is going to be 512. So there we go. The value of x up here is 512.